Very good morning friends, and again in this video we are going to discuss some special forms of the integration. This is our third video and we are still hooking towards the basic of the integration. So the first one form I'm saying that suppose if you have the form like x to the power 4 plus x to the power q plus x plus 3 divided by x plus 1 integration. How will you find the integration of this one? If you see the form, what the form it is, this is called the form of rational fractions, where this is a numerator polynomial, or you can say this is a numerator upon denominator. This is a fraction, or you can say the function, and this is another function. We will use the idea of the division algorithm, which says that the dividend can be written as the quotient times divisor plus remainder. So the idea goes like that: if this is divided, if actually x to the power 4 plus x cube plus x plus 3 is divided by x plus 1, it means instead of going for this form, I can directly find the division x plus 1. So just divide it, you are getting x cube here. So x to the power 4 plus x cube, subtract, minus minus, these two cancel, you just have x plus 3, then plus 1 times, then you get x plus 1 here, 1 into x plus 1 is x plus 1, minus minus, this is getting 2. It means x to the power 4, this one, this is divisor, this is dividend. This dividend can be written as divisor into quotient plus remainder. Means I can write this as x cube plus 1 x plus 1 plus 2 over x plus 1 dx. Now break this down into two fractions, this upon this plus this upon this. So this is x cube plus 1 times x plus 1 divided by x plus 1 dx plus integration 2 over x plus 1 dx. So this cancel, and then you have to find integration of this one. So it is x cube plus 1. I can write integration of x cube dx plus integration of 1 dx plus 2 times integration of x plus 1 dx. So the integration of x cube is x to the power 4 over 4, x to the power 4 over 4. Integration of 1 dx is just x, plus integration of 1 over x plus 1 is 2 log mod x plus 1 plus c is constant of integration. So this is the answer of this kind of integration. So now I need to take another example. For that I need to clear the screen. Suppose I have a form of integration which goes like integration of ax plus b dx. How will you do that? So for that you need to find out, is it possible to find the integration of 1 over root x dx? The answer is yes. This is nothing but x to the power minus half dx, and if you find the integration of this is x to the power minus half plus 1 over minus half plus 1, this is x to the power half over half, that is can be written as 2 root x plus c. So integration of 1 over root x is 2 root x plus c. If you want to use the property of the integration which I just discussed in the previous video, that you write the integration of this one as it is. So since you know that this is a formula, so you can say that this is integration of this is 2 under root whatever it is, so ax plus b, and then you write upon divided by the differentiation of this, that is a plus c. This is your answer. But I would like to go into the more formal way using the method of substitution. So what I do that, so I write let ax plus b equals 7 and then a dx equals to dt. So ax plus b is not 7, it is t. So ax plus b is t, and then a dx equal to dt. So what I have now is 1 over root t dt over a. Keep 1 by a outside, and then integration of 1 over root t dt. So I have just discussed that integration of 1 over root x dx is 2 root x plus c. So integration of 1 over root t dt is 1 over a into 2 times root t plus c. Now put the value of t there, and then you'll get the same thing, 1 over a 2, so 2 over a and then root ax plus b. This is how this kind of question can be achieved. Now I take another form where you find that they look like this, but you cannot apply this very same form there. Now I have another form where the form goes like root ax plus b minus root ax minus b dx. Now how will you find the integration of this form? Because this cannot be broken down into two different roots, because this is an algebraical expression, this is irrational expression. And what I need to do, that if we have an idea that you have done in the standard 9 or in the previous standards, that when you get these kind of forms, then you need to rationalize them. They use the term rationalization of the surds. So to rationalize the terms, what we do is that when you have the sum or difference of two squares, then you multiply them with their conjugate numbers. Like if you have the root a minus root b, when you have the root a minus root b form, then you multiply it with root a plus root b. This is called the conjugate of a surd. So when you have the form root a minus root b, this conjugate will be root a plus root b. When you have this term root a plus root b, its conjugate will be root a minus root b. And when you multiply these two, the roots will vanish, because this idea is algebraical identity, that is a minus b multiplied with a plus b gives you a square minus b square. So this one gives you root a square minus root b square, and that is a minus b. So using the very same idea, first we'd like to rationalize the denominator. Then what I have to do, that I need to multiply it with root ax plus b plus, because this is minus, so I'll take plus up and down. So ax minus b here, and then in the denominator you will have two terms, ax plus b minus under root ax plus b multiplied with ax plus b plus under root ax minus b, and this is your dx. So there the numerator remains as it is, because you can't do anything there, ax plus b plus under root ax minus b. But in the denominator you find, again you get the form of root a square minus root b square. So I write a minus b, means I write this and this only without any square root sign. So I'll have ax plus b and a minus, so this is ax plus b. So I made one silly mistake, this one should be negative minus, yes, that's fine. So when I just put a minus sign before that, this will become ax will become negative and the b will become positive. So this is b, and this ax and ax cancel. So again you see you are getting the forms like root ax plus b upon 2b. So I write 1 upon 2b here and the dx, plus again 1 upon 2b, and then square root of ax plus, sorry, this is minus b dx. Now what is the formula of, what is the integration of square root of x? So square root of x integration is 2 by 3 x to the power 3 by 2. How? So integration of square root of x is integration of x to the power half dx. This is x to the power half plus 1, and this is also half plus 1. So this becomes x to the power 3 by 2, and this 3 by 2 will be reciprocal, give you 2 by 3x to the power 3 by 2. So here I will write the answer directly, 1 over 2b and then 2 by 3 ax plus b whole to the power 3 by 2, and then again you have to divide the whole thing by the differentiation of ax plus b. So you get 1 by a plus same way 1 upon 2b, 2 by 3, 1 upon a, and then you can write ax minus b to the power 3 by 2 plus c. So first let me refresh it with the red color. So the final answer will be 2 and 2, this cancels, so 1 over 3ab, 1 over 3ab, and this here also you have same constant terms, 1 over 3ab, so I can take this as common, and then there you can write ax plus b to the power 3 by 2 plus ax minus b to the power 3 by 2 plus c, as constant of integration, and this is your answer. So I hope you understood this well. Now I take another form Okay, I have another example. This is looking like a very tiny example, but let's see how you do this. It goes like x upon under root x plus 1 dx. Now how you do that? So you can do it this way, that you can write numerator x as x plus 1 minus 1 over under root x plus 1. Just we are trying to get the form. Always keep, I'm always using the term form. Just find a better form, find a acceptable form, and then apply the formulas, because formulas, mathematics is all about matching the pattern. So you have to find the patterns, recognizable pattern. So this is x plus 1 over root x plus 1 dx minus 1 over root x plus 1 dx. Now this upon this will be simply root x plus 1 dx minus 1 over root x plus 1 dx. So now we have two simple integrations, and one is integration of x to the power half dx. This gives you 2 by 3x to the power 3 by 2 plus c, and another one is the integration of x to the power minus half dx form, and this gives you x to the power half into 2 plus c. And since you see the differentiation of x plus 1 here and x plus 1 both are 1, so we don't have to divide anything by 1, or dividing by 1 does not make any difference in its output. So we'll simply write the form which goes like, for this case it's upper 1, that is 2 by 3 x plus 1 to the power 3 by 2, and for this one it is minus 2 x plus 1 to the power half plus c, that is constant of integration. This is the way you can solve this particular problem. But in all the cases, because all the cases cannot be solved, we are solving as much as we can, and then you have to learn and develop the habit of finding the forms so that you can apply the formulas. This is all about the perspective. Thank you very much, and in the next video we'll take some more trigonometric forms.